guess we can start. So how many of you have been in the previous two lectures? Great. So the next question, which doesn't really make sense, how many of you prepared the assignment for the quiz? Okay, so in fact we have three groups, right? You have slides also, right, for presenting for presentation. Do you have anything to present? Okay, not can finish. And how about you? So, may I know who has slides to present the assignment? And this is one group.
Yep.
Okay. Yeah, next time I will ask them to introduce some grading in these models. Maybe it will be more encouraging. Okay. Anyway, so those ones who do the assignment, even if you don't have slides, I wish you come in the end and talk about it, talk about difficulties, findings, and so on and so on. Because first, it's interesting for us, since we provide the data set. Second, it's interesting for everybody, because it's basically about what the whole course is about. Today is interesting day, because except me, there will be some wrap up by the head of our lab in Singapore, Prof. Jonathan. He's sitting in the back, so he'll come later. And before I was talking about internships and jobs we offer. So if you have any questions, I guess he'll help you to clarify all your doubts about this, and we can talk about it, ask anything. Because he is a final decision maker, because he is our boss. Okay? So last time there was supposed to be 3 lectures, but the material was a bit heavy, so we go deeply in machine learning and in the source fusion. Okay, fairly deep. And we didn't introduce the 6th one, the case study. I think I will introduce it today. It's based on our recent papers. I'll go probably fast compared to previous lecture, because we also need some time to wrap up everything, and we need some time for presentation of 3 groups that we have. So the whole thing here, if you have been in the previous lectures, I guess it will be very clear for you, because I go in detail on each step of this paper. For those who haven't been here, I guess it will give you the brief picture about what we are doing in our projects, and also what we were doing in our recent work. And please ask any questions offline, online, and also there is my email here. So all the job, all the internship things, and regarding the paper, you can ask me here. Okay, so today's lecture is based on these 3 papers, mainly on the first 2. Because the 3rd one is a Russian paper. It was published 1 year ago. It was a very preliminary study about some community detection and the recommendation of the venues where a person will go. So it's about the mobility. The first 2 papers, I guess I mentioned before. The first one is the paper that we present in ICMR conference this June. International Conference on Multimedia Retrieval. It was in Shanghai, and it's about multi-source learning for inferring some user attributes. In particular, was about inferring the demographic profile and some mobility issue. And the second one was presented as a poster and covered with a short paper in a web science conference. It was held in Oxford in the beginning of July. So it's both a recent paper from this. You can take a picture, or you can remember, or actually all these slides are always available on my webpage, so you can just download, check it if you're curious, and we can later discuss. So first I will talk about user profile. So user profile can be basically many things. It can be some sensor data, some social graph. So in our work we will focus on these 2 attributes, which is the demographic aspect and the mobility aspect. Mobility itself is quite wide thing. It can be different things, but usually people talk about it as various type of movements. But in fact, for example, social science, they say that mobility could be the movement between different social layers, before different classes on occupations. And that even can be a movement of chess in a chessboard, very wide. Why it's useful for us? No? First, because it could be useful for urban planning. For example, if we have some dense regions where people visit often, but we don't have some facilities for them. It could be some cafes, some public things like schools or whatever. So we can use it to analyze the whole picture and distribute to facilitate people with such objects. Another one can be very popular recommendation application. For example, we can recommend some goods, services, or some locations, for example, the people where to go. So mobility basically can describe people, and it can describe people in terms of the movement, right? So you can see those here. So you roughly can say how long people move, where they move, what they do in all these regions. But if we introduce just one more binary attribute, such as gender, you already can see much more about these people. Just like for a third region, before we know that just two groups of people, now we can see these two groups of people actually of different gender. You can see in the right, it's all female users, in the left, and mostly male users. And if we bring one more dimension, just like age, right, so different age groups, we can see that it's very distinctive. For example, the age group of people of 20 years old is concentrated in the region 3. And others are walking around and so on. I'll talk about it later a bit. So the whole point is, actually demography is a very crucial moment in data analysis and in mobility. In fact, it's important to know the demographic attributes to do some second order conclusions around about the mobility issues as well. So suppose we have some user, and we know about him, just his gender and age. So we can say a lot about this user in different application domains. In marketing, we can maybe say that he stayed home and he do shopping and he pubs around. Just statistically, these people do this. And in urban planning, in wellness, we can say that this guy could be medium overweight and can experience some problems like hypertension. So in terms of advertisement, you can actually advertise something, could be unhealthy, but something you probably will buy to him. And we can assist him in a different way. For example, we suggest him to do morning exercise because his condition is not so well. In our study, we were doing twofold user mobility profiling. First, we were doing the demographic profiling, which was represented by age and gender. I'm sorry you cannot really see here because maybe we can switch off the lights. Can somebody help me to switch off the lighting here? Oh, yeah, that's too much. Yeah, actually I'm videoing about, so maybe you can switch on the.
No, but we can see the white, which is on blue, so just red.
Is it?
Because, talking about just myself, I can see only user profile, but none of the second line.
So if you do experiment and switch off all, is it better?
Yes,
and a bit better, but on the screen it is still not visible.
Okay, so maybe you just keep the half-half.
No, it's not visible at all, right?
Because
there's something wrong with the screen.
Yeah.
Yeah, I think that's a problem. Because I'm doing actually some videos, so you all can see this video later and see the slides at the same time, and then you finally can map it and finally understand what I'm trying to talk about. But yeah, the main thing you still can see this age and gender, which is the demographic profile, and some mobility profile, which is represented by the venue preference, the type of places where a person goes. At the same time, as I mentioned before already, most of the people in the internet, they actually use more than one social source at the same time. So it makes sense to assume that our data, our user profile, can be seen from different multiple views, from textual view, from geo view, like data from Foursquare, from image view, visual view, from Instagram, and all these forms are multiple views. So we don't have just text data anymore. We have multiple data sources, and all these data sources of different modality, like image data, location data, and text data. And all these forms are user profiles. So we believe we can actually enhance the overall performance of whatever that we do by integrating all these multiple sources rather than just use just one, for example, text or just location data. But at the same time, we experience some problems like we need to do this profiling in geographical view. Also, we need to do user demographic profiling. And at the same time, data is incomplete because people will never use all the social sources in the same way. And at the same time, we need to integrate together. So we need to know how all these sources influence the final result and balance them in a way we get the final, nearly optimal performance. It depends on how we will do it. This is a data set. All of you are supposed to know already if you'll be here before, but anyway, this is a data set based on which you are doing your assignments for today and supposed to do the presentations today. It's a multi-source data set from 3 social sources. One is Foursquare, which is the biggest location-based social network, biggest independent location-based social network right now. Because, yeah, Facebook is bigger, but this one is purely based on locations. We have Instagram, which is acquired by Facebook, but it still keeps being independent service and is the biggest photo sharing service. And also we have Twitter, which is the biggest English-speaking microblog. Yeah, you may say that there is Weibo that's actually bigger than Twitter, but in terms of English speaking, like Twitter is the biggest still, right? So we do all this and we process the English text. We didn't go into Chinese characters and so on. So we get the whole data set. Some of you are asking me how we collect the data, so I'll stop on this slide a little bit. The principle is very, very easy. You have a cloud with multiple crawlers. These crawlers basically web jobs in the cloud. Each of them has their own IP. So from each IP, we can run the Twitter Stream API, Twitter Stream. So we can monitor like thousands of users from each of them. And since we have different IPs in different parts of the world, the sample of users will be quite representative, bigger than the original one that Twitter provides. And the main point here is many users actually use so-called cross-linking functionality of social networks. It's usually at some tick. Let's say I want to publish all my check-ins or pictures in Twitter. So you put this tick once, and then you forget about it. But your phone is keep publishing everything in Twitter. Everything happens with your Instagram, publishing Twitter, and so on. So if we can notice that some user actually perform activity into social networks and publish both in Twitter, we are done with the mapping of the same user from different social networks. And that's how we collect our data set. We crawl all the users, all the seed set of the users that we found around 3 geographical regions, Singapore, London, and New York. And when we found that some of these users use multiple social networks, we just remember their ID mappings. And after that, we keep crawling the image data, and location data, and Twitter data. So we get the multi-source data set. It's unbalanced, but it's somehow multi-source, and many of users have different types of features. Yeah?
Is it legal to collect the data on various users?
That's another issue, but it's all public data, so, and we don't publish this data. It's legal to collect it and do research on it. We publish the data set, and we publish it in terms of features, which are completely anonymized. Of course, if we work ourselves on it, right, we can use the raw data. But if we publish with others, we either collaborate with these groups and we work on raw data, or we can just publish the features, which is not related to actual person. I'm sorry. whole thing looks like this, and actually sometimes it's with this resource. You can use other sources. It will work quite well for this. So these are numbers of the Singapore part. We have 3 social sources. We have tweets, check-ins, and images. And for Singapore, this is Singapore data, part of the data set. We have quite many tweets, and quite many check-ins, and quite many images. We need to mention that our users are actually certain category of users which are very, very active in social networks. And we found them in a certain way. We actually was search for such users, for this user seed set. If you take the average users, they may not use as much, all resources as much as these users. So it's also related to how we collect them. But it's basically an issue that is related to most of the papers in our field, so we cannot avoid it unless we are Google. So we have the whole distribution. And this is another sub-data set, London. So London users were less active as compared to Singapore. But we still get some numbers so we can do research on it. And there's one more in New York, which is where is the headquarters of Foursquare is located, so we can get quite a lot from them as well. So obvious advantage of this data is you can do multi-source and multi-region research. Especially it's interesting for those who do social science, because you guys can analyze it and see actually how people behave differently in different countries. You can do some correlation analysis and see what is more important for them, discover topics that we already instruct for you, and so on and so on. And if you get raw data, you can do it more. So how many of you actually social scientists or psychologists or something? Okay. Okay, so it's a good for both of you. And for all your friends. So this statistics of data set cannot say much, but you can see that, for example, for some sources, it's interesting, like for number of media contents and number of tweets, Instagram and Twitter. Female users are actually more active. But for Foursquare it's opposite, female users more active. And you see different age, like, for example, those users who use social media and who is 30, 40 years old, or even over 40, they in general more active than the younger users, which is surprising, and the reason is, again, the same. Our users are not evenly distributed among all categories, so many of elderly, they don't use all the social services, but among those who use, they're actually in average more active than young people. Probably they have more time, or it's more fun, I don't know. So we start with demographic profiling first, and it's time to represent features, represent data by using some features. And it's very important, right? Because you cannot work with the raw data. So how many of you have machine learning background? Oh, that's nice. Yeah. Yeah, so you could be interested to work on it, so we always welcome you to try yourself for some internships or jobs. Now I can get my name part of Dr. Prof. So we were focusing on 2 attributes, age and gender. And we have different data types, right? I was covering this before, so I'll go over it briefly. First, we was using the LIWC features. LIWC features is a very simple thing. It's basically the distribution of words in our text corpora among different categories. I guess we have 74 categories. And this can be like numbers, or some social words, or family-related words, or how many they use I, we, you, and so on and so on. So different types of words, which are heuristically inferred by some social scientists. One of these main social scientists is so-called John Pennybacker. He didn't put slide with him, but you can find the earlier slides in the previous lectures. So it's a social science guy. He was even writing a book about how different types of people use different words. And he came up with some interesting conclusions, like for example, if you tend to lie, you use certain types of words when you say truth. Or if you are generally have following character, you will use word I more often than if you are leader. And this is all statistics, so it's based on the US population. It doesn't really matter. I guess it could be expanded to other people. So they come up with this dictionary of 74 categories. And surprisingly, this dictionary is very, very good in distinguishing different psychological, different personality types, like extroversion, introversion, and other some other types in the border of psychology and sociology. So it's one type of features. We extract these features for each of our users, for each textual data from each of our users. And another one is the topics. How many of you know what is LDA? Yeah, by now everybody's supposed to know because I was talking in the first day. LDA basically is an automatic generative probabilistic model that automatically assigns topics to text you're writing. So you have some text, and they assume that when you write a text, you have some topic in mind, and each topic is represented by distribution of force about this topic. So when you write text, we assume this, and then we suppose we have text already written. So we reverse the whole process, and by using so-called keep sampling, we actually recover the topics hidden in your text. So for each user, we combine all his tweets in one document. Then we have as many documents as users, and each document will have a distribution among different number of topics. The number of topics here is 50. It must be given. So in our case, it was determined by perplexity. But there's many measures, and there's a lot of discussions about what's better to detect the number of topics, and the parameters are playing better for the Dirichlet distribution. So that's another independent topic. We can write many papers in school about it. So by now we have LIWC features vector and the 50 topics vector, the distribution of our documents among these topics. And we also come up with some features that we do by ourselves. Here are the names of these features, but yeah, you cannot really see it. Anyway, you can read the descriptions in the right. So this feature is basically related to our writing behavior. For example, how often we do mistakes, how often we use slang words, or how often we use different social features like hashtags or user mention and so on and so on. So from here, what is interesting, for example, we found that those who are younger, they do less grammatical mistakes as compared to those who are older, which is theoretically should be opposite. But we get one psychologist before in the previous lectures, he actually says that, yeah, older people, they don't have time to care if they're writing, so that's why. And it's very distinctive, you know, it's only this feature can distinguish very well the two categories, those ones before 20 and after 20 years old. Just one feature. So it makes sense to come up with some empirical stuff that can help us to do this. Another thing we analyze is we do some sentiment analysis and count sentiment words, average sentiment of person, and so on and so on. Sentiment analysis, again, is like independent topic. You can go very, very deep, so if you're curious, you can go read, or you can talk with me, we can discuss, we have some insights in it as well. Next type of features is location data. So in this work, we didn't leverage on the actual location of person, the movement of person, but we were doing the study of the categories of places which person visit. So for example, I go to a restaurant once, and I go to this is restaurant. No, this is restaurant, and I go to airport twice during the whole time of monitoring of me. So if I divide each of them by 3, total number of chickens, I somehow get the distribution among 4 square categories of places. And it will be something near to distribution of my location preference, my interest. The 4 square category 3 looks like something like this. And we pick up all the leaf categories, so it's hierarchy. So we pick up all leaf categories, so the most fine-grained categories. And these categories have different interests in categories like prison, or like, I'm not sure who she came from prison, but yeah, maybe relatives who visit there. Yeah, or maybe they get a phone so they can check in. And we get K-pops, and we also get disco pops, and big variety. And some check-ins are even made in events. So they create a category of event, and then this event will have a certain name. So many different types of high breaks, so it makes sense to use it. And one more type is interesting. So how many of you have the background of some image processing, image retrieval, and so on? Oh no. And nobody come the first day. Okay. So the idea is basically easy still. We have different images, many different images, which are taken on Instagram, just like this one. It's actually two posts. One is postdoc from our lab, another one is professor from Singapore University. Are running together. So I take their picture and put it here, so they become famous recently. Basically, we extract from this image different representative features. Like from here, you can see different edges. Edges as something that distinguishes the objects from the background. Like hands or the contour of the trees, right? And also we can see different colors. So we can build a histogram of colors of the image. Then we can extract something called shift features, which is rotation and scale invariant features. So for example, if you get one more guy like this, scaled and rotated in another picture, we still can match the same thing. How it works? Okay, I guess you can download my slides or read about it because that's all obvious. But the basic idea is we detect edges of the objects, and then around these edges we compute the gradient and the magnitude of gradient. So we basically see in which direction the objects change. So we get this gradients and we map these directions and magnitude to the histograms, and then it's a kind of histogram of edges, and it appears to be scale and rotation invariant with a certain constraints, of course, but somehow it's very popular type of features. And then it's easy. Then we combine all these features together and train many models. In our case, it's 1,000 models because there's such a data set called ImageNet that have pictures and concepts like a ball, or human, or something, or tree, assigned to each image. So we can train 1,000 SVM classifiers, for example, and each of them will say, is it tree or not tree? Is it ball or not ball? And so on and so on. So then we pick up those classifiers that are really confident in their decision, right? And we decide, okay, this image probably has this concept on it. So which concept we can see in this image, for example? Yeah?
3 people building hill, this road.
Yeah, so the idea is like this, right? So for each image, we can get the distributions among these 1,000 concepts. And then we can compare them, right, by using cosine similarity or, for example, Euclidean distance or Chebyshev distance, which is a very interesting one. Sometimes also very bad. So it's like it's a subject of discovery for us. And that's all that we combine everything together. We linearly combine everything together. So how we determine weights? To determine the weight for each classifier, we perform so-called it's heuristic. It's called hill climbing. The idea of hill climbing is like this: we randomly assign parameters and then try all the neighbors of parameters. If some of these members give us the increase of some cost function, and this can be everything. It's not necessarily convex. It can be like accuracy of the classifier. Then we update that parameter and try everything again. So it stops when no any change of parameters can help us. So it means we get the local maximum of the function. So there is some studies that say that if you run this thing many times, like 1,000 times, based on different based on different random assignment in the beginning, we are very likely to get something close to the global maximum of the whole thing. In our case, it's true because later, after we publish the paper, I actually check I ran the grid search of these parameters, and I found that our results are just a bit worse than that is the method that's the optimal assignment, but it's for different sources. So we get all these sources, we get the probabilities of each label for each source, and multiply it on the weight that we found, as well as the normalized number of data records of this source. So we get how we kind of consider the amount of data records we have, the same as the confidence of the source, as well as the performance of the classifier after the tenfold cross-validation. I assume you know what is cross-validation, right? Yeah. So don't know, check my slides before. And the whole thing looked like this. And the interesting moment here is this yellow tree. It actually can be bigger here. What we found in the end that we don't have too much exact ground truth for user age. So because it's very sensitive information, so not too many people show their age in the Facebook. We collect our ground truth from Facebook. So that was a problem, but we come up with a solution which works quite nice. What we do, we extract their education and occupation information. Then we manually build some decision tree that basically can predict us the rough category of user age, or the age of the user, based on their education and occupation. It's like if you finish school 2 years ago, you probably shouldn't be older than the age of finishing school plus 2, right? So it's like this. And actually for different cities it's different, so that's another issue here. We do it for Singapore. The approach for Singapore doesn't work as good as for Singapore, for London, for New York, because people go army different time and finish school different time and so on and so on. So we train on the labels that are inferred from education and occupation of these people. But we do evaluation based on those users who really say the exact age. And we predict the age group of the people. For these age groups, below 20 years old, 20 to 30, 30 to 40, and more than 40, can be splitted before 10, 10 to 20, and so on, 6 age groups, but the number of users was not too big. So we kind of balance it by introducing these 4 groups. And you can see the results. The gender prediction results are quite promising at 0.82, which means we quite confidently can tell you gender based on the data that we publish. Not necessarily text, but can be also two more sources. So some users have all the sources, some have only 2, some will have only 1. And you also can your age group out of 4 with this macro recall. So that's quite nice. And what is the most interesting thing for us? Sorry, these results 8.878 and 0.509. What is interesting for here is that this multi-source result is comparably better as compared to different combinations of source, like here. For example, this is combination of text and media, text of an image, and each source independently. For example, it's just text is a brown thing, and also better than all the like baseline classifiers like name base, sphere, and so on and so on. Which tell us that it makes sense to integrate many different sources together to enhance the performance. And even we have unbalanced data, even we have not too much data for each user, even we don't have some sources for each user, in general it helps us to improve. So I guess after this paper, there should be a necessary requirement to do multiple sources. And in fact it is in our multimedia community. Most of the papers try to leverage on multiple sources rather than do one data source. Just because we live in time when you have to do it. So how about mobility? We can talk about demographic mobility a bit. That's the second part of our profile. I'll go very brief because this one is more about visualization rather than machine learning. So we have the city, and this macro level of city is Singapore. Singapore is a country and a city at the same time. So it's very nice to do research there, because we can do country level observations. So
you can see different distribution of female and male gender among different areas of Singapore. And how do you think what is number 1 and number 5? Those who know what this is, don't tell me. Because probably somebody already knows the answer because I read paper already. What is the region number 1 and number 5?
Bars.
Yeah, it's only male chickens there.
Reasons?
It's garages.
Again?
Garages.
Garages. Yeah, I guess for Russia.
Bars.
Huh?
Bars, maybe.
Bars.
Radio.
Bars, not precise, not correct answer because I'll show you later. It's actually distribution. We also highlight bars.
So industrial zone where people check in and work, or I don't know.
Yeah, so only male.
Uh,
Female cannot check in and work.
No, but just because on the plants they're more male than female, and
But it's just male.
Maybe military zone.
Yeah, and this is correct. Actually, you can see from a map. You see, it's with the red lines on it. It's actually a military zone which is forbidden to enter anybody except who is serving army. And Singaporean military system is quite nice, so people can check in from army. Yeah, in Russia here you probably cannot check in from army. But they can. I don't know. I mean, I don't know how it's now anyway. And they can go home in the weekends, so it's very nice, very convenient. And how about the smart? What you can see here. Well, here, as I noticed before, it's interesting region like region number 3, where you have distribution of female and male in some region. So what we found here is that actually female users like to check in some family spending occasions, some family time spending occasions. So if it's resort, it will be for sure much more female check-ins than male check-ins. I don't know, it needs to be verified. I guess those who do social science, please take our data set and tell me the exact answer why it's like this. I'll give you all data, no problem. So about age, you can see that the age is quite evenly distributed. But those who are older, they tend to stay in the city center, which is here. Those who are younger, they go, they evenly distributed around the city. Especially those who go to school before people are 20 years old. So they visit different occasions. And they visit these school-related places and also condominiums and ADB flat where they live. And they check in there. But interesting thing to see is in a global level. So here we see, here we have Singapore in region number 3. And we also have two Malaysian cities in the region number 1 and in the region number 2. And it's very interesting to notice that those users who are younger than 20 years old, they all stay in Singapore. And then those who are older 20 years, probably finish school, start working, they start to heavily travel to all the nearby cities. So you can see them in Kuala Lumpur there, 20, 30 years old, the green points. And you can see here in Jakarta where people go over there for shopping quite often, and so on and so on. I guess if you're curious what people do in different cities around Singapore, you can also craft you up because they have experience about it more than me. Okay, so all of this say to us that, yeah, it makes sense to consider mobility and demographics at the same time. And I encourage everybody to use this data set to do more studies on mobility research with consideration of demographic aspects, occupation, and so on and so on. So jointly we can get much deeper insight as compared to just do on single source and a single application. This is some statistics about the image concepts and Foursquare check-in types that user perform in our data set for Singapore. So you can see that many female users have the weak concept in their pictures. So it's a WIG, so it's basically artificial hair. People
But it's not necessarily artificial, right? Because for our consent detector, it just detects something that looks like hair. And you can see a very strong disbalance between male chickens with hair and female chickens with hair. It means girls actually take selfies and they take other girls or something. There's a lot of this stuff in their pictures and we detect it, and it's a very distinctive feature for us. That's why actually images work quite well for gender detection. It's a very useful source for us.
And the same thing you can see for age, like for example, if you go to Foursquare, you can see that those one who younger than 20 years old, this one is a residential building, so it's their home. They quite often check in at home, just like in the map you see before. But 30, 40 years old people, they check in at train station, and they check in at cafes, so they start walking somewhere in the street, they travel all the time and so on. So it's very distinctive. Both sources are very, very distinctive. That's my whole point. I want to say that text is not enough. We need to consider all this stuff to do a really nice observation about some personal attributes of a person. So what we did, except this, we just apply the LDA directly allocation again, but based on the Foursquare check-in data. So for this case, the users was document, and the types of places where people go were the words. So document consists of 3 words, which is train station, and 1 word shopping mall, and 1 word club, for example, and so on and so on. So we do LTA on it. So we get the distribution of users among these 6 topics. Number of 6 determined empirically by just manually observing topics and say which of them makes sense, which of them not. So topic 1, topic 2, and topic 3 can be, and so all of them can be briefly characterized and named in such a way as how we name them. First one was the food lovers, because it's a lot of restaurants appear in their check-ins. Other were travelers, they go airport, hotel, cafe, and so on. Other guys were party goers, because the most popular was a nightclub, and also food court, and also they also go to school sometimes, so they actually
Correlation.
yeah, I mean, that's the point. The thing in LDA is that different words may belong, the same word may belong in different topics. It just, you have different probability of occurrence of this word for this topic, but not necessarily, it's not exclusive, right? So just read about it, it's like very easy thing. So.
And other guys stay at home, in the office, or in building, which is also home, so they are family guys. So we also have students. Okay, sorry, the youth and youth, so I should go to students. I'm sorry, that's a mistake here. We also have students who stay in university or college or in gym, and we also have those ones who often go to high school. So we call them teenagers. Teenagers doesn't mean that they are certain age. Teenagers mean they have teenager behavior, which is they go to school, because in English both university and school are schools, and in high school and university you are called student, but we need to name categories differently. That's why we distinguish them in this way. But it doesn't matter how we name them, because the most interesting for us is the distribution among these categories. And you can see that actually every user is differently distributed among these categories. One users are more party-goers, like a user 3. These are 3 random pickup users from our dataset. Other user could be a very professional, very shifted towards professional side. And third one can be like food lover. So if you see the global distribution data set, you can see get interesting insights. For example, here there's more female professionals, office guys, as compared to male one. And it's surprising. I was thinking that male actually will check in professional sites more often than female, but actually it's not. So it's interesting, it's distinctive. It's some insights we can get from data. Another thing, for example, food lovers are all 40 older. So you can see the age, how more food lover you are is proportional to your age. You become older, you like food more. That's what I mean. Okay. Whatever, it's like this from our data, right? And you can see that, for example, students are below 20 years old. They have a big there. Yeah.
Actually, isn't it strange that not all are?
What do you mean not all?
Not all students are less than 20 years old, as this chart shows.
Yeah, it's not strange because it's not students, it's topic called students, which belongs of these categories, which is not just only student.
Yes.
So it's distribution, it's topic, it's already high level category.
The places where the students go. So
yeah. So the reason is, okay, it's not really students, it's people who have certain behavior and we call them students. And
yeah.
so it's already topics, it's already not the actual value category because we need to reduce dimension to visualize it and see interesting things. So that's what was we doing in the first paper. And the second paper was kind of one more step towards mobility. I go very brief through it because I don't have too much time already. So we have a user who don't know where to go. And he has some venue categories. He decides which of these categories he wants to go. So what we want to do, we want to recommend these categories to him. These categories are picked up from the Foursquare. So in other words, we have some timeline and we have some categories and also tweets and also images in this timeline. So, and we split it based on training set and test set. So our goal is train on train set, which is the first part of the time, and predict the future, which will be in the second part. And the future, the prediction, the actual thing that we want to predict is the Foursquare venue category. So it's around 700 categories. So you need to pick up and rank them and give the rank list. Or it also can be considered as user profiling because we need basically to build distribution of user interest among Foursquare categories. Right? So it's kind of similar. So how many of you know what is collaborative filtering?
Not much.
The idea is very simple again. We have two users, and both these users are cyclers. And they're similar in this point of view. And one of them like pizza and salad. And another one also like pizza and salad. And then for this guy we also know that he likes Coke. So why not we recommend Coke for another one? Because they are similar and they have similar preferences. And you know, all these big guys, they don't do too much beyond this. If you have big data, collaborative filtering will work very, very well. So if you are recommended with something in some service and you think, oh, how come it's something so similar to my interest? Just because you're similar to somebody who already bought something that you are recommended now. And there's two types of collaborative filtering. One is called user-based, another one called item-based. So the difference is in user-based, we compare users. We have user-level features. In item-based, we compare items. So we'll compare Coke, some representation of every item. But idea is the same. Find something similar to you, check something in this similar which you didn't do before and recommend this to you. So we generalize it and we do it for multiple sources. So we get the recommendation list for each data source and then re-rank them according to the position in output list. So for example, if one guy is recommended with restaurant, mall, and for example, cafe from a text source, and restaurant, mall, and train station in image source, and then search source something else, we will combine all these positions drag together, and then sort it in ascending order, and give the final result. And of course we will weight each of these sources because we assume that each source has actually different impact on the final result. And it's very easy, but it works. So you can see the multiple sources actually outperform all the baselines, and the very strong baseline, which is collaborative filtering based just on location features, actually perform worse than collaboration filtering based on multiple sources. So what you can say here is something like, yes, you somehow can recommend the place where you go based on pictures you take, or based on Instagram, or based on text that you post. And this area, of course, is just first steps. It's actually very important to come out with releasing. It supports both these types of research. And many of you are mathematicians, research, machine learners, information retrievals, and so on, so on. So please take this data set because by now it's the only one that is includes publicly accessible and includes this data from 3 sources and allow us to do all these applications. Actually, we have also the occupation, the interests, the relationship of a user, and the school, the education level. And in our paper, we cover ancient gender, so if you cover all, it will be very nice. If you want to collaborate with us on this, please contact me. I will be very happy to do. I think all of us can contribute. If you want to go internship and work on this project or other project you have, please contact me and we'll do it. If you want to go work on this project or something else, please contact me and I will also can discuss it with you. We actually need nice, smart, creative people because, yeah, we need them, everybody needs them, right? So, what we are doing now is basically very similar. And yeah, take a picture of this. This is a link to our webpage where all the vacancies and internships are described here. And you can take a QR code. Yeah. Or you can drop a mail to me from my webpage or from the first slide. Or you can remember it. Technology is so nice, now we can just take a picture of it. So we can post it in Instagram, they will process it again and predict something about you. Okay? So we can do the extended user profile, right? We can do like personality, social status of this person. We can do some cross-region research. In fact, one Russian guy is going to Singapore soon. We are doing this cross-region mobility analysis project with us. And we can detect user communities and see what is similar between users. It's also really interesting. Another interesting thing is the wellness domain. It's very popular now, and it actually was initially proposed by Ramesh Jain in his position paper, where he proposed to integrate social media and sensors together to get the results. And we have social media and sensor data sets already done. And I guess it will be first data set. I think we will try to come up with some paper at CIGIR. And that one is also a very interesting research project. You can join it. We're going to analyze sensors and social media to predict some attributes of you. And framework could look like this, where we perform user profiling for multiple applications and connect to different well-structured knowledge in the wellness domain to come up with a final recommendation for user. And this is types of tasks you can do. So you can do profile using learning, you can do research on data fusion, which includes the machine learning research. It's actually integrating our models. So we try to find some nice convex models that can optimally help gently learn the pace of each source and combine them together to come up with the final attribute. And it should work nice. So we are looking for people who can do such a modeling. So we can do some individual and group mobility analysis, so mobility analysis of individuals and user groups, and we can do some cross-source user identification, because we have mapping of different sources, so we can actually try to detect the same user in one source, given the information in other sources. quite a popular research topic. What else we have? We have the community detection, which I also already covering. But it's not necessary to work with the data in a user level. We can see the timeline of data and try to find some causality relationship between data types. It's like I add hamburger and then I get heart attack. Or yeah, I'm happy if you find this in our data. Yeah, something like this, right? So this is a relationship between different events in different types of data. And we can do some privacy-related research, as somebody just mentioned in the beginning, because this topic actually gained popularity. It's actually very important. What we can publish, what we cannot publish, how to work with data in order to protect the user's privacy and at the same time get useful insights, how to visualize, present the data in a way people can get some insights from it, but we will not cover personal aspects of each user. So the wellness profile project is like this. Some users don't really know what's happening with them. They don't really know the actual physical state of them, and they try to call doctors, and doctors prescribe something, but users actually don't know how to use it. And there's nobody except wife or children who remind them to keep a certain way of staying. So our idea is we have some sensor data set that will help you to keep yourself living healthy, and will also help you to suggest you what you need to eat, and so on and so on. So that's why we need joint social sources. The sensor data is not enough for us. We need your social media to detect the type of food you eat and other aspects. So we integrate everything together and we try to build the physical user profile. In particular, it could be something like obesity level of person, because obesity is a very common physical attribute of a person. So it could be useful to detect a person's obesity level, how fat he is, to prevent him from such a big list of disease, including high blood pressure, type 2 diabetes, and chronic heart disease, and several types of cancers, and so on and so on. So basically, obesity related to everything. Yeah, we better be slimmer. So it can be one of examples of attributes, like obesity, also can be asthma, diabetes. In fact, in our group we work on these three. Ramesh Jain, the American professor, he's working in asthma mainly. We are working in diabetes, obesity, and depressions. And it could look like this. When we integrate all sources together, just as I saw before, and we can detect BMI categories. So we are working in our project now.
A question.
Yeah.
How can you understand that the user will have an asthma or diabetes? How can you crawl such a data source? From one data sources you can crawl such a data set.
Okay, this attribute is just an example, but actually sometimes we have some nice knowledge about the users, so we can crawl their profiles and know these attributes from users. Right?
But isn't it really that you can know about user that he has, for example, diabetes? So people usually don't tend to tweet that they have diabetes.
Are you sure? There's a huge diabetes communities in the web. You may think in this direction. I mean, anyway, it's heuristic and it's always need to think how to get this data, how to verify that this data is relevant enough to do research and nice observations. But the idea is like this. And of course, in social media research, because of privacy and data visibility, the ground truth is one of the biggest challenges for us. Because even if we have data, we don't really know who actually these users are. And even in previous research for gender and age, to detect age, it was a problem for us. We actually have to see education and occupation to get the age, to train the model and predict the age. So yeah, your point is correct. And here I give an idea, right? Some people come up with a group of people who are paid to give their data for research, right? In some other cases, they maybe reveal this information in their public profiles. In some other cases, people may mention it in their messages. I'm not sure, right? There's many different ways, so it's possible. We can discuss offline if you want. It's possible. It's not such a big problem. And
problems are like this, right? We need to fuse the data, and this now is even more difficult to fuse it because we have this sensor data, which is not social media, actually, it's really physical data. How to balance the model in a way still make it work the best for the world? That's the problem. We need to predict some attribute like opacity profile. We need to gather the data, we need to, it's sensitive and there's noise, and you are right, that's correct. So, as summary, I would say that we construct such a data set for our first profile, and we do some user mobility and demographic learning, and we come up with conclusions that actually multiple data sources help us to improve the overall performance. And we actually think that it's possible to integrate sensors and social media data in future. So that's our current research. Again, want to join, just contact us. If you're curious, yeah, we can discuss. So the next session will be wrap up of everything, and it will be held not by me, but by Prof. Short. I guess we can have short water break. I guess I'm already more than 1 hour lecture. We have total 2 hours. So in the second part, there will be consist of 2 parts. First, Prof. Short will introduce his opinion about it and wrap up everything. In the second part, we will have 3 teams that will present their solutions of the assignment that's given in the first lecture. So it's everything interesting for all of you to see how much people can do just in 2 days, having a good data set and having some knowledge of how to work with it. So I was thinking to do some short tutorial on KNIME, but it was supposed to do in the second day. Now I guess I'll just leave it to you, so you download slides and read. And this app is very, very useful for social scientists, because you can download data set and by 1, 2, 3, 4, 5, 6, 7 steps get the result, which is took 5 minutes to me. From the data, get the actual gender and age with accuracy 0.64, which is not 0.5, which is higher than 0.5, right? Which is not bad. It's a very simple model, so you just get a bit more knowledge and use it, and you'll come up with quite nice results. And hopefully you'll outperform our paper, because that one is the initial study. So this is a summary. One more point, that KNIME is useful. So if you're a social scientist and you can use it, please use it. This is the description. Of the opportunities that we have now. So again, go to the web page and read everything. I hope you'll find something interesting for you. And we have some short breaks in the Prof. Short can continue. Thanks.